and sharing my screen. And I am going to ask you folks to watch me like a hawk today. I think I woke up on the wrong side of the bed. I've been doing all sorts of careless things. I think my first class, after about 5 minutes, they said, "Are you sharing your screen?" It's been one of those days, so I apologize in advance. Today we're going to
back here. Excuse me? It's Ryan. I signed in late. I didn't know if you got me.
Yeah, I got you. I got everybody who came in late. We all
Okay.
waited.
All right, thank you.
Okay, so today we're going to look at trig applications. I think today we're going to be looking at the last new content of the semester. Wow. After today, 5 classes, right? Because the final is going to be on Wednesday, the 16th. If anybody's interested, we can still meet on Friday, the 18th. I will be around to Zoom if you want, but it won't be mandatory. Exam 4 is going to be due a week from today on the 11th. It will be open from the 9th till the 11th. On the 9th, we will in class probably go over their preliminary problem set. If we don't do that on Monday. Actually, we should probably do the problem set on Monday and then on Wednesday answer any remaining questions and start reviewing for their final exam, looking at their preliminary final. Homework 5.1 is due today. That's the one on angles that involves radian measures and coterminal angles. Homework 5.2 is on right triangles. That's kind of everything that we've done thus far. And homework 5.8 is on applications, which is what we're looking at today. Problem set 4 is also due on the 11th, but again, it's to help you get ready for that test. The more times you can do it, the better you will do on the test. So I would do it before the test, not after. The last class that you can do My Math Lab homework will be the 14th. After that, I'm going to submit zeros for missing assignments. And if I submit zeros for missing assignments, you can no longer work on them. Please realize that before then, you can still miss a late assignment. It'll say past due. If an assignment says past due, you would still get credit for it. Even if it's really, really late and you work on a back assignment,
That's good.
labs with a late penalty might not be giving you credit.
What pen are you using?
Somebody's not muted. Could everybody please make sure that you are? Even if it's really, really late, I promise at the end of the semester that you would get at least half credit for a late assignment. And so after the 14th, I will look at their noted when there's a note made on the instructor gradebook. If an assignment was completed late, I'll look at all of those. And if it gives you less than half credit, I will award you more credit for that. Some people feel like their My Math Lab average is good, but if there are missing assignments in there, realize that when those missing assignments get replaced with a zero can really bring down that average quickly. So the test is due the end of the day Friday. The last of the My Math Lab, it's getting closed on Monday. Over that weekend, if not before, go through and start looking at those back assignments. It'll also be a great way for you to review for the final. Any questions about any of those dates? If not, let's real quick take a minute and open the assignment manager. Does anybody have any questions on any of the homework?
Number 10 in section 5.2.
It's been open too long. I need to reopen it. I'm sorry, I had it pre-opened, but sometimes if it's been open too long, it knocks me out and makes me redo it again. So 5.2, question 10.
Yep.
Okay, it should come in now. Find a cofunction with the same value as the given expression. And so we've got cosecant 37 degrees. Well, that's cosecant. And so its cofunction would be secant. And remember we had said that in order for cosecant to equal secant, the angles have to be complementary. So I'm going to take 90 minus 37, and that'll give me 53.
Why do you do 90?
Because do you remember, I'm going to give you a very, if I look for the cosecant of A, cosecant is the reciprocal of sine. So sine of A would be little a over c. So cosecant of A would be little c over A. Now, if I look at angle B, the secant of B would also be c over A. And that happens because what's opposite angle A is adjacent to angle B in the right triangle. So far, does that make sense?
Yeah.
But because it's a right triangle, I know that A plus B plus C has to equal 180 degrees. And because C is 90 degrees, if I subtract 90 from both sides, it tells me that those two angles add up to 90 degrees. And so because that relationship is going to hold in any right triangle, that the acute angles are complementary, and the co-functions, what's adjacent to one is opposite the other type of thing. The co-functions will always be equal if the angles are complementary or if they add up to 90. Okay?
Okay, thank you.
So because it asks for the co-function is secant, and in order to be equal, you're going to have to subtract the angle from 90 and take the complement. Better?
Yeah.
Okay, great. I have to apologize. That was something that we looked at last class. And because of technical difficulties, I think you guys remember that my computer overheated and I lost y'all in the middle. I was unable to save the recording of that class. So the written word is there, but the audio is not. I'm sorry for that. Does anybody want to look at anything else for homework? If not, let's pick up from where we last left off. And if I remember correctly, we were using calculators to find function values. And I know we stressed that the mode is important. And so I'm going to ask you folks to use your calculators to do a couple of things for me. First, let's ask everybody to find the sine of, let's say 21 degrees. To 4 decimal places, what are you getting? I'll do the hard part, 0 point.
3583.
Beautiful. Except I think we're going to round that to 8.4, right? Because next digit is 6.
Yeah.
What if I ask for the tangent of, let's say 1.2? And is everybody right? There's not a degree in here. And so this is a radian measure. And so that's when we want to change our calculator from degrees to radians. And for that, is anybody else getting 2.5722? Then let's look at another one. Let's look at the secant of 60 degrees. And at this point in time, our calculator doesn't have a button for 60. I'm sorry, it doesn't have a button for secant. I misspoke. It doesn't have a button for secant, but we remember that secant is the reciprocal of cosine. And so going back to degree mode, I'm going to type in 1 divided by the cosine of 60 degrees. And so that's giving me 2.0000. And I think that was kind of where we left off last class. Does anybody have a question on any of that? What we did not look at last class is finding the angle if you know the function value. And so because it's a function, we could say, for example, I know that sine x is equal to y. And x is my independent variable, pardon me. Y is my dependent variable. I put an x to find y. Well, if I instead know y and want to find x, we're going in the opposite direction. And since we're going in the opposite direction, we have to use what's called the inverse function. And so, again, the notation for the inverse function is a little bit beyond the scope of the course. It's something that you're going to see in Math 111. If you take the advanced algebra and trig, you'll spend a lot more time talking about those inverse functions. But notation would, if I were to say, y is the sine of x, I would say x is the angle whose sine is y. The notation would be x equals, and for that inverse, they use an exponent of -1. And so on a function, when you have that exponent of -1, it means inverse. It does not mean reciprocal. It doesn't mean I'm making a fraction. It's not like a computational exponent of -1 on a function name. It means we're using my function backwards. So if I know the function value and I want to find the angle, to get to the inverse function, on your calculator, you're going to press either the second or the shift, depending on the type of calculator that you have, button first. And so if everybody would take a minute to look at their calculator, if you look at the sign button, in tiny print above it, it has sign to a -1. Then that does not mean reciprocal, it means inverse. And so if I'm looking for the angle, I'm going to press second first to get to that inverse function. So let's say, for example, I want to find theta if sine theta equals 0.1234. Let's find theta to the nearest degree. Well, because it says degree, I want to make sure that I'm in degree mode. And then with my calculator, I have to remember to press that second or that shift button first, then my sign, and then your calculator display should show sign with that exponent of -1, and then type in your numbers 0.1234. So clear second sign 0.1234. Is anybody else getting that theta is equal to the nearest degree, 7 degrees? So let's again find theta to the nearest degree. If I know that cosine theta equals 1/3, then I'm looking for the angle. So, and I'm looking at to the nearest degree, so I want to be in degree mode. Looking for the angle, I'm going to press the second button first. Then here the function is cosine. And then I'm going to enter 1/3. I usually do that by 1 divided by 3. And so I'm getting to the nearest degree, 71 degrees. Is everybody else getting the same? And then let's do one more. Let's find theta to the nearest 100th of a radian. If, let's say, tan theta equals 2. We're looking for the angle, so we have to hit that second button first. But realize this one's asking for it in radians. So make sure you change your calculator from degree to radian. And then we'll press second tan 2. And is anybody else getting 1.11 to the nearest 100? Everybody all right? Let's do one more. Let's find theta to the nearest degree. If this time we're going to get all crazy. Cosecant theta is 8/5. Looking for the angle, we're going to press second. But my calculator doesn't have a cosecant button. What am I going to do? Well, cosecant is the reciprocal of sine. So if cosecant is 8/5, wouldn't sine be 5/8? Again, because those are reciprocals. And now I'm looking for the angle, and I want to be in degrees. To find the angle, I'm going to press second sign, then I'll put in my 5/8, and I get theta is 39 degrees. Is that all right? If so, we're going to then look at solving a right triangle. And again, this semester, we're only going to be able to solve right triangles. Anybody who takes the advanced algebra and trig, math 111, will be able to go beyond that. But right now, we're keeping our focus on right triangles. So we want to label the triangle carefully. We want to pick the correct function for what we're looking for. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, or your SOHCAHTOA. And then substitute what you know and solve the resulting proportion. If needed. So, am I talking too fast? Or is everybody ready for this example? Not hearing any complaints? This one, we're going to start with the picture. Again, right now we're only able to look at those right triangles. I'm going to know that this angle is 29 degrees. I'm going to know that this side is 27 inches. And I want to find x to the nearest 10th. Well, I have the hypotenuse, so I know it's either going to be sine or cosine. The side that I know is next to the angle, it's the side of the angle, so it's adjacent. And so that tells me that I'm going to use cosine adjacent over hypotenuse. So that gives me that the cosine of 29 degrees is equal to x over 27. Now I said to solve the proportion. When I look at that, what I see, what I think, is that the cosine of 29 over 1 equals x over 27. And to solve the proportion, I think of cross multiplying. So that gives me x equals 27 times the cosine of 29 degrees. And so now I'll take my calculator, make sure I'm in degrees, and just type 27 times the cosine of 29. My calculator, when I type in the degrees, it opens up parentheses. Good habit to get into is closing that. And so I'm getting x equals 23.6. Is everybody else getting the same? Not hearing any complaints. Let's try another one. This time we're given a right triangle. This time we know our legs are 10 and 29. And we want to find this angle up here, theta. Again, it's a right triangle, so I know I'm going to use my trig because I don't have the hypotenuse, but rather the two legs. I know that I'm going to use tangent. Tangent is opposite over adjacent. And so that gives me the tangent of theta equals 10 over 29. This one, because I'm looking for the angle, I'm going to stop right there. I know the function value. I'm looking for the angle. I want to find theta. I didn't put in rounding words, I'm sorry, to the nearest degree. And so because I'm looking for the angle, that's when I have to press the second button first. So I'm going to press second tan, gives you that exponent of -1, which means we're doing the inverse. We're looking for the angle. We'll put in the function value 10/29. And is anybody else getting theta is 19 degrees. That all right? Then one more of these. Let's say I have my right triangle. Let's say I know that this angle is 50 degrees. Let's say I know that this side has a length of 10, and I want to find my hypotenuse. Well, from the angle that I know, I have the opposite side, and I'm looking for the hypotenuse. And so opposite and hypotenuse is sine. So let me say sine is opposite over hypotenuse. So filling in the numbers I have, the sine of 50 is 10 over x. Here, when I cross multiply, I get 10 is equal to x times the sine 50. Should probably make note of the fact that those are degrees. And so now to solve for x, I have to divide both sides by the sine of 50. And so I get x equals 10 divided by the sine of 50 degrees. And again, you're best off solving for it in terms of sine and typing that in, as opposed to rounding off early on. We should leave it in terms of the function until our last answer. We'll be giving a much more exact answer than if we rounded that decimal off. So I'm going to take 10 divided by the sine of 50, making sure that I'm still in degrees first. And so that would give me x equals to the nearest whole number, 13. That one all right. If so, we're also going to be looking at applications, which is a fancy name for word problems. And in his book, Mr. Blitzer makes use of the idea of bearings. And I'm guessing that some of what's in this section on bearings is probably an old person thing. Am I correct in assuming that most of you folks, if you're trying to find out where you are or where you're going, you use GPS on your phone instead of pulling out a map? With bearings, we're looking at things with relationship to a map. And so when you look at a map, has everybody seen in one corner or another a directional that tells you where's north, south, east, and west? And usually north is up, south is down, east is to the right, and west is to the left. When I look at my bearings, they're in order to triple. When we were plotting points, we had said that our coordinates were in ordered pair. We had two things, an X and a Y. With bearings, we have three. The first one will always be north or south. The last one will always be east or west. And the middle one will always be the degree measure of an angle. from the vertical or the north-south axis. And so this isn't at all like putting our angles in standard position, but rather we're working from that north-south axis. So let's look at some examples. Let's locate. Let's say I have south 30 degrees west. So I'm going to draw my north, south, east, and west. And because this is referring to the southwest, at its most basic, is everybody all right? Southwest would be in this quadrant. That's 30 degrees though. So I'm going to start on the south, and I'm going to picture an angle opening towards the west that measures 30 degrees. And so it would be somewhere, your location would be somewhere along that line. Instead, another example. This time, let's locate north 75 degrees east. And so this time, I'm looking at northeast, so I expect something to be in this quadrant here. I'm going to start at the north, and from the north, I'm going to open an angle 75 degrees towards the east. And so I would be somewhere along this line. One more example. This time we're going to work in the other direction. I'm going to ask you to find the bearings of point P. And so my diagram, I'm going to have my north, south, east, and west. And my point P is going to be here. And the picture labels this angle as 25 degrees. With this one, though, you have to be careful because, well, is it obvious to everybody from where it's located that we're going to be in the southeast? But for bearings, I'm always looking at the angle from the south towards the other direction, towards the east. And so I need this angle, not that 25-degree angle. What I failed to point out at the beginning, I'm sorry, is the fact that we're going on the assumption that while I can't draw and it doesn't look it, those are supposed to be right angles. And so if that's a right angle, does anybody have a suggestion as to how I could find this missing angle in my bearing that I need? No suggestions? Well, if this is the right angle, it's a 90-degree angle. Wouldn't this remaining angle be 90 minus 25, which would give me 65 degrees. So be careful when you're working with bearings. You always want the angle that's drawn from that vertical. Either direction. We're not talking directed angles here. We're not thinking of a positive or a negative angle. If the first letter is S, we're worried about the angle with one side on the south axis. If the first letter is N, we're worried about the angle with one side on the north axis. All right? And then one last picture that I'd like to draw. And it deals with the difference between the angle of elevation and the angle of depression. And so whenever I talk about the angle of elevation or angle of depression, usually most of these questions deal with something that's on the ground and something that's drawn going up. We're usually going to assume that the thing that we've drawn going up is perpendicular. And if I'm referring to the angle of depression or the angle of elevation, for one, I need a person standing on the ground. We'll make it a happy person. And for the other, I need a person standing at the top of whatever this structure is. Sometimes it's a building, sometimes it's a tower, sometimes it's a mountain. It can be all sorts of different things. Give this person a hat. And when we're talking about the angle of depression or the angle of elevation, we'd be kind of like considering the line of sight between those two folks. Now, if I look at this person on the ground, if they were to look straight out, in order to look at the other person, they have to lift their head up. So since they're lifting their head up, they're going up, they're elevating their sights. And so this is the angle of elevation. Instead, if I were looking at the perspective of the person up top, if they were to look straight out, to look at the person on the ground, they'd have to be looking down. They'd have to depress their eyesight. And so that's the angle of depression. No matter where it's drawn, you should be able to picture a right triangle. Sometimes it's this right triangle on the bottom that I've drawn. Sometimes we can look at it as this right triangle up above. Please notice that with the triangle that I have drawn, one of the two is not going to be in the triangle, and so you're going to have to do a little bit of arithmetic to find the other angle. But angle of depression would be looking from the ground upward, how much you tilt your head up. Angle of depression would be looking out and then tilting your head down, the angle that you would have to put your neck through to look down. Is everybody all right with the differences between the two? Not hearing any questions. I don't know if anybody noticed, we skipped a page in here. This document 4 is a sheet of problems that if we were on campus, I would give as a handout to work on in class. But since we're not on campus, we're gonna do it via Zoom. So let's look at this problem over here. We want to find b to the nearest 10th. I know that angle A is 21 degrees. I know that angle C is 90 degrees. I know that my hypotenuse is 238 inches. Again, in order to solve the triangle, I need to know 3 things. And so here I do have 3 things, 2 angles and a side. Now, I'm always going to go from the perspective of the angle that I knew. No, the angle that I know is angle A. And so B is the adjacent side, and the 238 is the hypotenuse. So adjacent and hypotenuse tells me that I'm going to be using cosine. So here, filling in what I know, the cosine of angle A would be little b over, I guess we'll call it little c, or the cosine of 21 degrees is little b over 238. So cross multiplying, I get little b is equal to 238 times the cosine of 21 degrees. And so now we'll take our calculators, make sure we're in degree mode, and take 238, multiply it by the cosine of 21. And so I'm getting B is 222.2 inches. Is everybody all right with that one? Then I'm going to skip the next one for a minute. If there's time, we'll pull back. Third one, we've got a word prompt. It says a tower is 100 feet tall and it casts a shadow of 102 feet long. Find the angle of elevation of the sun to the nearest degree. In my math lab, for a lot of these, I'll have the pictures drawn for you. They're more generous than I. If I were giving this to you on a pencil and paper test, you'd have to draw your own picture. So with these, we're going on the assumption that we're on level ground and the tower is straight, not leaning, so that we have a right angle. We know the height of the tower is 100. Is everybody comfortable with the idea that the shadow is on the ground? And so this distance along the ground is 102. Angle of elevation means that I'm looking up, and if the shadow is to the left, the sun would be on the opposite side. And if I connect the tip of the shadow to the tip of the tower, that would give me the angle. In this diagram, I don't know anything about the hypotenuse, but in the triangle formed, I have my 2 legs. And so with the legs, we know that we'll use tangent is opposite over adjacent. And so the tangent of the angle I'm looking for is the opposite side would be 100. The adjacent side would be 102. And again, this is the angle of elevation because it's from the ground looking up. Now, with this one, we don't have to cross multiply because everything that's on that right-hand side is numeric. The variable is on the left. Because we're looking for the angle, we're going to find the inverse function. If you want to be fancy pants, you can say that the inverse tangent of 100 over 102 is equal to theta. And you can do that, but I'm perfectly fine if you just stop with the circled equation. But because I'm looking for the angle, I have to make sure I'm in degrees, and I press second tan. And I'm going to type in my fraction, 100 over 102. And to the nearest degree, is everybody else also getting that theta is 44 degrees? That one all right? Not hearing any questions. This next one's a little bit different because it says use the right triangle and the given information to solve the triangle. When they ask me to solve the triangle, what they're asking is for me to do is to find all the missing parts. And again, with these, in order for them to work, I have to know 3 things. And I'm looking for the other 3. So now wait a minute, over here I know that A is 10. Is everybody familiar with this symbol? Looks sort of like that, and it's called beta. And it's a letter of the Greek alphabet. It's kind of like an uppercase B in Greek. And again, a lot of times we use those Greek letters for angles. So this angle down here is 63 degrees. And initially it looks like they only gave us 2 pieces of information. But remember, the third one is that we know that the other angle is 90 degrees. Now we want to find B. We want to find C. And this symbol over here kind of looks, to me, it sort of looks like a fish. I don't know. This is another letter of the Greek alphabet. It's alpha. And it's just a variable for angle A. Again, a lot of times when you're looking for angles, they use the Greek letters. And so we'll use the Greek A or alpha. How we solve this is very much a matter of personal preference. What would you want to find first? B, C, or alpha? Anybody have a preference? Not hearing any, I'm going to start with the low-hanging fruit. The easiest thing is alpha. In order to find alpha, I think we already mentioned that the triangle sum of the angles is 90 degrees. And so that question that we looked at the beginning of class with the cofunctions, if we've got that, the sum of the angles, I apologize, is 180 degrees. And since the total of all 3 angles is 180, what we had talked about at the beginning of class is that if this one is a right angle, the other 2 have to add up to 90 degrees. And so we'll be able to say that alpha is 90 minus beta, which gives me 27 degrees. For the other sides, I'm going to make use of my trig. I guess if I go through and find them in alphabetical order to find B. Right now, to find B, we could either use angle alpha or beta because we have them both. But I usually like to, if at all possible, use only the given information. And so the given information is beta and A. And so A is the adjacent leg, B is the opposite. And so I'll use tangent. Tangent is opposite over adjacent to get that the tangent of 63 degrees is B over 10. Cross multiplying, B would be 10 times the tangent of 63. Again, we want to make sure that we're in degree mode. 10 times the tangent of 63. And they didn't give us round off words. Let's find it to the nearest tenth. Is everybody else also getting 19.6? And again, I'd like to make use of just the given information. And so using the given information to find C, I'm given adjacent. C is the hypotenuse. I'll use cosine. Cosine is adjacent over hypotenuse. So that gives me that the cosine of 63 is 10 over C. Cross multiplying, I'll get C times the cosine of 63 degrees equals 10. And then dividing by cosine of 63 degrees. I'll get C is 10 over the cosine of 63 degrees. And so again, making sure I'm in degree mode, I'll take 10 divided by the cosine of 63, and I get 22. I guess to the nearest tenth, it would be 22.0. Is that one all right? Would anybody have found C any differently? Can anybody think of another way I could have found the missing side once I had to? Okay, then we'll just leave it at that. I'm going to skip the next problem and look at these next two because they're both a little bit more involved. In the upper problem that's being shown, we're looking to find this distance x. And does everybody notice that x is the side of this tiny little triangle up at the top? That's not a right triangle. And we don't only know how to find parts of right triangles. So what I'm going to do is I'm going to look at two right triangles. First, does everybody see this great big outside right triangle? In this great big outside right triangle, I'm going to let y be the length of that leg that contains x. Then I'm going to look at this tiny little bottom right triangle. And in this tiny little lower right triangle, I'm going to let z be the side of that same leg. And looking at the relationships, does everybody see that x plus z equals y? Or I could say that x is equal to y minus z. Now to find y, I need to use the big triangle. I'm involving both the legs, so I'll use tangent. And in the big triangle, I'm using that entire 26-degree angle. So the tangent of 26 would be opposite over adjacent would be y over 590. Cross multiplying, I'll get y equals 590 times the tangent of 26. And believe it or not, I'm lazy. I'm going to stop right there. Now I'm going to look at my green triangle, and the green triangle has that 22-degree angle. And so in the green triangle, I'll have the tangent of 22 is equal to z over that 590. And so when I cross multiply, I'll get z is equal to 590 times the tangent of 22. And then since x equals y minus z, y is 590 times the tangent of 26. Z is 590 times the tangent of 22. And again, I got sloppy. I didn't put the degree symbols in there, but all of our angles are in degrees. And now I'm going to just type that right in the way it looks. You have to be careful though, because on your calculator, when you type in a trig function, a parentheses opens. You want to make sure that you close those parentheses. So I'm going to go 590 times the tangent of 26, and I've got to close that parentheses, minus 590 times the tangent of 22. And again, I want to close that parentheses. And so that gives me that x is equal to 49.4 to the nearest 10th. This may be a little bit more typing, but we don't have to worry about copying down all of those digits from the trig function product. And we don't have to worry about rounding. Because I typed this in the way it is, I did not round until the very last answer. And you should not round till you get to that very last answer. That one all right? If so, I'm looking, I wrote too big. So I'm going to try to do a little bit of magic stuff here. I'm going to cut that and just move it up a little bit higher. Yeah, and that gives me a little bit more work down below. This next one's tricky. I want to say that I do believe there's one like this on your homework. And when you see one like this, especially in a book by Mr. Blitzer, realize that we might use a little bit of prior knowledge before we start pulling out our trick. What I think makes this one tricky is that what we're looking for is not a side of either right triangle. So we don't have a full side of either right triangle. So with a question like this, I'm going to find some missing angles first. And so if I look at this little green right triangle, we've got two angles. So to find this angle here, I'm going to take 90 minus 66, and that gives me that little angle is 24 degrees. Then I'm going to look at this great big right triangle. And first, let me find this entire angle, and then subtract to find this little angle here. So first, to find the entire blue angle, again in a right triangle, the two non-right angles add up to 90. So when I take 90 minus 33, I get that that angle is 57 degrees. Now this little red angle would be the difference of the two. And so for that red angle, I'm going to take 57 minus 24, which gives me 33 degrees. Does that 33 degrees look vaguely familiar? Well, this angle down here is also 33 degrees. And does anybody remember from somewhere in your past mathematical career that if two angles are congruent, then those opposite sides must also be congruent? And so if this side is 370, this side here must also be 370. And that side that's 370 is the hypotenuse of my little green triangle. And so now, again, I want to go back to the given angle in the little green right triangle. I'm looking for the opposite, and I now know my hypotenuse. And so I'll say that sine is opposite over hypotenuse. So the sine of 66 degrees is x over 370. And so cross multiplying, I get x equals 370 times the sine of 66 degrees. And so we can just work from there. And I get that x is 600 and no, it isn't. There's no way that can be bigger than the hypotenuse. And I realized I did something careless in looking up above. It's because I typed 670 instead of 370. I'm sorry. X is 338 to the nearest whole number. How's that one? I'd like to do one more together with you folks. And it's the last one on the page. And I like to do this one because it involves our bearings. It says a boat leaves the entrance to a harbor and travels 100 miles on a bearing of north 57 degree east. How many miles north and how many miles east from the harbor has the boat traveled? So I'm going to picture my boat. And it's at the mouth of the harbor. And since that's where we're starting from, that's where we'll draw our directional. And I'm going north 57 degrees towards the east. And now the question is asking me how many miles north, if this is where my boat is, 100 miles away, how many miles north of the harbor and how many miles east of the harbor am I? And so in order to get that, I'm going to draw myself a right triangle. And you notice that 100 degrees is the hypotenuse, and 57 degrees is one of the acute angles. If I let x equal the distance north, and I'll let y equal the distance south. Not south, hello, that's not south, that's east. In my right triangle, I know the hypotenuse. Here to find x, I'm looking for the adjacent. And so cosine is adjacent over hypotenuse. So it gives me the cosine of 57 is x over 100. So x plus multiplying would be 100 times the cosine of 57. And making sure I'm in degrees, I'm going to type 100 times the cosine of 57. And I get 54 to the nearest mile. And then in the same way, y is opposite. And so opposite and hypotenuse is sine. And so the sine of my angle, 57, would be the opposite side y over the hypotenuse, 100. And cross multiplying, I get y equals 100 times the sine of 57. And again, that's degrees. And I get to the nearest mile, 84 miles. And so we are strictly north, 54 miles north of the harbor. Strictly east, we would be 84 miles east of the harbor. And how's that one? Any questions on any of the problems that we've looked at today? Hearing none. Anybody want to go over anything more?
Yeah, I got a question.
Sure, Miguel.
Did you get me for the attendance today?
Let me check. Yep, I did.
And I could do that? I could do it right. Would you be able to open the system quiz up, and I could do it like right now?
Let's